Alright, I did want to go over a little bit about these rectifiers and this solid state one, homemade. Typical 5U4, this one's a 5U4 GB. It has a slightly higher PRV than the standard 5U4. Just about any 5U4 will work in this amp. I've put shoulder tubes in here, the old 5U4, plain old shoulder tube types, and yeah, they did okay until they get a little gassy, in which case it blows the fuse. So, but anyway, basically what's in here, two rectifiers. They share a common cathode, which is also the heater. This is a directly heated cathode. There's no separate cathode sleeves like in some rectifiers and just about every other modern, or I'd say more modern tube you would use. So there's 5 volts across pin 2 and 8 here, and that serves to heat up the cathode, which is both the heater and the cathode. And then, of course, a couple of plates. These would be attached to the in the secondary of the high voltage of the power transformer. The high voltage winding on the secondary would both ends of it would attach to one end to pin 4, one end to pin 6, and the center tap of that winding would be at ground, would be your 0 volts. And then the high voltage is taken off of either pin 2 or pin 8, the rectified high voltage, and then that feeds into the capacitors, the filter capacitors, and on feed B plus voltages to the plates of the various tubes. Ignore this for right now. That's what's in here. I'll explain a little bit more about that in a bit. Let me get this out of the way. Let's see. One could get away with doing something as simple as this, ignoring the heater and just make a common cathode to pin 8, and then 4 and 6 go to where they would normally go. So each one of these silicon rectifiers, diodes, tiny little things, takes the place of the two diodes in the 5U4 tube. In this case, I would use two 1N4007 diodes. Those have a PRV, peak reverse voltage rating of 1,000 volts, which is remarkable given their size, and I kind of doubt that that's a good idea. But for the voltages they'll see across them in reverse, keep in mind, whatever the output, AC output of the power transformer is, these are going to see about twice that because of the filter capacitors. I'm not going to get into the details of that, but trust me, if the output is 400 volts, you want at least an 800 volt rated diode, if not more than that. So 1N4007s would cover this. It would draw no power whatever from the heater winding, which is for the 5U4 almost always a separate winding on the power transformer. Draws quite a bit of wattage. So you have to think about that. But this would be the simplest method, and conventionally, from my experience and what I've been told, that B plus would be taken from pin 8. This would feed the rest of the circuitry. It really doesn't matter electrically whether you take it from pin 8 or pin 2. It's the same. The trouble is, when you go to do these solid-state rectifiers, which one do you pin this to? If you know the device you're working on, if you're familiar with it and you can see it, looking at the bottom of the tube socket, You can determine that. Where's B plus coming from? I've seen where it comes from. They pull it from both pins, and it makes no sense to me why they would ever do that. Because then you've got this 5 volts AC that's the cathode heater itself. It makes no sense to me. I don't know what they were doing there, but typically this is how it would be done. If you've got an instrument such as this Dukane here, where they do not pull B plus off of pin 8, they pull it off of pin 2, well, with this as it was configured, would not work. I had I'll draw it in here. I had a small lamp here just to indicate that the 5 volts was being supplied. I had it, I stuck it in there. Well, I was assuming, big mistake, I was assuming that this was drawing B plus off of pin 8. Well, turns out it's not. It draws it off of pin 2. So that meant not only was there 5 volts across this lamp, B plus had to get through it to get to pin 2, which was feeding the rest of the circuit, the other 2 plate supply. So, well, that's not going to work out well. Now I could make this for this amp specifically. Oh, but why do that? I want this to be kind of universal. So that's why this business here. And there are more diodes here than you need. The reason the way I did it the way I did was because I can't find my bag of 1N4007s, the 1000-volt ones. I got a bunch of these 1N4005s. Well, those are 600 volts. Probably would have worked just the way I showed it, but safety in mind and longevity, I doubled up on them. But the key point here is that the DC voltage, both rectifiers, supply both pins and allow the 5 volts AC across pin 2 and pin 8 for the heater. It does not need a load on the heater circuit. I put a 5 volt lamp in there just as an indicator. I had it handy, stuck it in. That's this guy right here. The rest of it's all down in here. You can see the kind of crossing of these silicon diodes. You see how small they are. This does not, under the highest load that this amplifier can ever draw, this does not heat up at all. Well, the lamp does a little bit. That's that lamp, 5 volts, draws about 220 milliamps. Specialty bulb. But it was handy, and I got no other use for it, so and it goes. Just a reminder that there's power on, I guess, nothing else. Plus it's pretty. So, that's it. I doubled up on these because of the lower voltage reverse voltage rating on the 1N4005s. That's why there's an extra diode here and an extra one here. You could short these completely out. Just have a wire, this one and this one, and just use these 4 diodes, and it'll accomplish the same thing if you've got diodes that are rated for well above the supply. Just to be on the safe side. I could have eliminated these with the diodes I have. I just wasn't real comfortable with that. You get a spike in the power supply, it could zorch them. And so it is the way it is. In an earlier video, I mentioned inrush current being a potential problem when you're using this sort of circuit. Don't worry about that too much when you've got a transformer with a secondary impedance that's a little high, as these tend to be. So if you've got a rectifier that's going directly across the line, meaning the line voltage in, 120 volts or whatever it is, feeding into a largish capacitor, you do have to really worry about inrush currents. The fact that this is the feed into this circuit is coming through this transformer, that is sort of a limiting, current limiting situation. So don't worry too much about it. More of a concern is that what are you doing to your filter capacitors? Are you overvolting them by using solid state? Keep in mind, the voltage drop across this is quite a bit less than it would be through a vacuum tube. I see if my memory serves me well, is something in this application, something like 20 volts. Not a whole lot, but it makes these much softer on the rest of the circuitry, so use these in long term. This is good for testing. I know guys that'll put the diodes, they'll screw the tube, they'll just put the diodes in the chassis under it and add resistors where this diode and this diode are. That can work, and not the best solution in my view to do that. So anyway, that's what the rectifier. If anything else occurs to me about these beasts, I'll include it. But I think this is going to be the last video for this particular beast. So it's on. It's been on for a little while. Just let it warm up. Still got my 8 ohm load tied across the 8 ohm speaker output. But I've also connected a 8 ohm speaker here, this lab tech beast. Just a little computer speaker. I was going to bring up my one of my cabinets, but I thought, no, I'll just do it this way. It's won't bother the cats as much. So this speaker is tied in across the 4 ohm tap, so it just gets a little bit of a sip of the full power output. Most of the power is going to be into these resistors, or this resistor. Let me pull the scope on. Don't need a signal generator or anything right now. I already did all that. Let's see. So again, most of the power out of this amplifier right now is being dissipated by these resistors. This resistor. A little sip of it will go into this little 3, maybe 4-inch lab tech computer speaker. There's no amplifier in here. It's just a speaker, and probably rated at, oh gosh, maybe if 5 or 10 watts. I've taken these tube shields off just to see. I've only got this one dual or twin triode end because I'm going to be using one of the microphone inputs without a transformer. It's going to be high impedance guitar, not a low impedance microphone. And the cable I'll be using is the whole deal. It's XLR to 1/4 inch phono or phone. So, wow, before I plug that in, a little bit more about how quiet these are. Now that this is on, speaker's connected, the scope is tied across the 8 ohm load here, and you see it's flat line, nothing. All of the volumes are turned down. I'm going to pull up mic 1. Now that's the channel that this particular tube is plugged in. Mic 2 and 3, there's no tube, so there's nothing going to happen with those. But a little bit about this. I'm going to turn this. Now there's nothing plugged in, input-wise. There's no tube shield. There's no top cover to shield these things. Now, bearing in mind that these jumpers here one of them is connected directly to input. And so having the outside cabinet or some sort of shielding out here does make a difference. But I'm going to crank this all the way up. Now, I hear some stuff. Well, of course there's a hiss. But hum. Not a lot. Very, very, very little. None of it's coming from here down. It's all coming from this guy. Even if I approach this tube with my hand, or this part with my hand, it's coupling enough AC, 60 hertz AC into it that you can hear it. And this tube, while designed not to be microphonic, in quotes, is a little. It's hard to avoid that completely. Higher quality ones are quieter in that regard. Piece of crap ones like these, they don't do well. Especially when you have the amplifier chassis mounted into the same cabinet where the speakers are, or speaker is. Vibrates the cabinet, the speaker vibrates the cabinet, it feeds back into the tube, and you get howling feedback. So it's important that a lot of gain here that be not microphonic. This isn't terrible. I mean, the gain on here is pretty high right now. As evidence, as soon as I draw my hand anywhere near this, you can hear it, AC. So go ahead and watch what happens. As I put this down on this tube, it's going to pick up through capacitive coupling me. I'm not touching anything but the floor, and I'm on the second floor on carpet, so there's very little leakage. Nevertheless, I've got lights here and 60 hertz wiring all about. It's going to couple through this shield into the tube until the shield becomes grounded. Right? See it increase in volume a little bit? As soon as I grounded that shield, all that stopped. Now, maybe a little hard to hear. I can demonstrate this. Now, the tube is fully shielded, but this isn't. If I touch that, it'll be very, very loud. So I'm not going to do that. But you can see it's picking up hum. Now, if I chassis myself, I'm no longer coupling 60 hertz in. And the thing, there is zero hum. Absolutely none. There's hiss, but that's unavoidable. It's part of the rules. Right? I don't even need to be in good electrical contact. This is painted. But if I draw my hand near this, let it pick up some hum, touch the painted surface, even that is enough to provide some shielding. It's not perfect. Now this is directly connected, all these are directly connected to the chassis, so that provides full shielding. Give you an idea just how sensitive the input of these are, or can be, especially with so many stages of amplification. So what next? Turn the volume down. I'm going to plug in an instrument, just a quick demo. While the amplifier's warmed up fully, not so much. But I can at least get through a few notes and demonstrate some of what these things will do. Got a guitar here to noodle with, and there are no effects boxes or anything, just these pickups directly in to the amplifier. Now keep in mind, most of the power is being dissipated by these resistors. a little sip of it is being fed through this small speaker. You can't expect a whole lot out of something like that. And the oscilloscope is also looking across the speaker, so you'll be able to see the waveforms on the oscilloscope. So give it a little volume. Now, like I said, this thing has got quite a bit of gain. I'm gonna set it to 1. Now this dial 0 to 10. That's 1. And it's very very clean. And plenty of volume. Given the setup here, believe me, if I put this into a cabinet without this load resistor, I'll drive the cats crazy and make my ears ring, so I'm not going to do that. Not now. Besides, the camera's microphone is, how shall we say this, crap. It does have automatic level control. You know, this camera, by the way, is a Canon something or another, cheap camera. And so I don't know how good of a job, or how well it's going to do capturing this. Like I said, I'm not warmed up. I'm not warmed up. Just noodle, right? I'll not play anything you'd recognize. So, nice clean sound, right? No, that's on volume 1. Let's go up to 3. Again, no effects boxes, no distortion stuff, no phase shifters, or no reverb boxes or anything like that. Now that might be overdriving the camera's microphone. Barely overdriving this. And even that, what's happening is the power supply is limiting its output. You'll see it clip if I hit a hard. See? See the clipping? Yeah, that's responsible for that muddy kind of effect. But at that setting, it gives you pretty good dynamic range. Get the idea? So you can go from clean to distorted, just depending on how you strike the beast. Alright, let's go up a little bit. We go to 5. This doesn't go up to 11, but I tell you 10 is too much. Goes up to 5 right now. And now all you barely touch the strings. You barely touch the strings in it. It's a little dicey. Wow. and plenty of mud there. Now, we're going to full Monty, put this thing all the way up. And 2 points about this. One, even at that, it's a whole lot of gain. The guitar on it, not so much trouble with shield and shielding. Still microphonic. Shield back on. And this, when you breathe on these strings, I know. You see what's happening on the scope. That's what drives the cats nuts. Oh boy, you talk about distortion. I'm not warmed up, but to a real shredder, this, they tell me it's sweet. I would tend to agree. I don't know what else. I do use these as a hi-fi amplifier, hi-fi stereo, in my stereo system. Usually I use 4 of them, sometimes more, sometimes less, depending on what I'm listening to. Very, very, very well behaved. As I said way earlier video, I will take this over any Fender. I don't care which one it is, amplifier. Not that there's anything wrong with them, but me being somewhat of a hacker and so forth, there's just so many possibilities. Because of all the tube sockets it's got, you could rearrange one of these things 18 ways from Sunday and come up with all kind of nifty stuff. It's got octal sockets in it, so you could try, you know, your 6SN7s or your 6SL7s and, you know, those older tubes, and have it switch between that or the more modern miniature tubes. There are other outputs you could put in here, some without modification, some you'd have to rearrange a couple of the connections on the underneath the under the chassis, but that's for hecker, it's no big deal at all. And if nothing else, I mean, the iron on these things is phenomenal. This thing, you could run it all day with signal through, and this output transformer stays cool. The power transformer warms some. Not too difficult to understand, given the current draw on it. Probably idling, it's probably 20, maybe 30 watts. Not surprising that this would get a little warm. And also, with the proximity to these tubes, which get hot. Now, you know, I can lay my hand on the top, not long, but you know, they're hot. But they're not smoking hot. You know, some of these old guitar amps, man, they run these things so hot, you do this, you get blisters. Not with this. As I said, this thing was meant to be run 24/7, 365 without grief, and not constantly be blowing through the tubes. So it, you know, there's some heat. But relatively speaking, she runs pretty cool. Yeah, no heat there at all. No shear debris. A little tiny bit here, but this resistor is very hot. Yeah. Not gonna spend too much time figuring on that that piece. So, oh, and by the way, there's no bottom cover on this. It's sitting on a wooden table. So I wouldn't expect too much grief. But there's no bottom cover on it. And in spite of that, the hum, even with this all the way up, well, let me unplug the guitar here. There we are. No hum. I'm simulating having the metal cover that goes on these in place, but quiet as a church mouse. No microphonics there. This one, a little bit of a microphone, but I wouldn't have a problem putting this in on sitting on top. Usually, what I do is I have this sitting on top of my cabinet. I usually use a 112 cabinet for this, just for noodling around, practicing, and it does not feedback at all. No matter how I crank it, doesn't matter. Other tubes in this place, crappy ones, it will howl, especially if you have more than one in it, which I have no reason to do. It's only just the one. I just keep these in place so I don't lose them. And plus it looks cooler. Looks like there's something in there. So that's this piece. As an aside, this thing, I got this quite a few years ago. It's a vintage one. I can't believe what people are asking for these things. I've played through a number of it's a distortion pedal. Played through a number of these, and to me, solid state distortion all sounds the same. My hearing isn't the best, so I'm probably not the best to judge. So I will occasionally play around with this 9-volt battery in there. Get these on eBay. There are reissues. Stevie Ray Vaughan used these things, and for some reason that lends this a whole lot of credibility. I'll say that this is probably the better of the ones I've messed with, but only because it's so rugged. I've had some that are pretty cheap and cheesy. You stomp on it more than once and it breaks. So I give it credit for being a very solid cast aluminum cabinet for it. I've had it for a long time. It works just great. But it does solid stately, or tries to, what this does naturally. It's a tube screamer, right? Meant to simulate overdriven tubes. Now, whether in the front end or the tail end, yeah, it's anybody's guess. These they work okay, but you really want the genuine article. Get a tube amp. It doesn't have to be this. Fenders work just fine. Some of the older ones, especially, with much weaker output sections, distort beautifully, in my opinion, at least from my hearing. But it's what I grew up with, I guess. So I think I'll leave that at that and wrap this up. I hope somebody enjoyed it and could get some use out of it. See you.